Hello, Algebra 2. This is 711, which is simplifying expressions with rational exponents. So if you're following along with the handout, our objective by the end of this is to be able to simplify an expression with an exponent that's a fraction. In Chapter 5, you worked with a lot of exponents that were positive and negative whole numbers, and now we're going to be throwing fractions in there. So one of the things that we want to remind ourselves of, or maybe this is the first time we're seeing this rule, is that if you have some kind of base and it's raised to an exponent, maybe your exponent is something like x over y, you could rewrite this as your base being raised to an exponent of 1 over y, and then that whole thing is raised to an exponent of x. And the reason why we can do this is because when you have an exponent inside parentheses and then one outside parentheses, you can multiply them. And sometimes it's helpful for us to go back and forth between these two forms. In some cases, things might be easier when your base and your exponent are written in this form, and in some cases it might be easier to have it written in this form. The other rule that we should review right here is that if you have an exponent that's raised to, or if you have a base raised to a negative exponent, that's the same thing as having 1 over that base raised to a positive exponent. And then if we have 1 over a base raised to a negative exponent, that's the same thing as having the base raised to a positive exponent in the numerator. And the way that we used to summarize these rules is that if your exponent was negative, that meant it was unhappy, it didn't like where it was, and you would just put it in the other part of the fraction and make it positive. Okay. So with this topic, there are so many different ways that you can do it, that the best way is to really just jump into doing several examples. So I'm going to jump into our classwork here, and we have a lot of different things to simplify. Now, for number 1, they give us 25 to the 1/2. Okay, so our base is 25, that's a whole number, and then we have an exponent of 1/2, which is a fraction. And with a lot of these in section 711, you have to do a little bit of backward thinking. You have to think backwards and think of the numbers that are raised to certain powers, our squares and our cubes, and what those equal. And so hopefully at this point you remember that 5 squared is 25. So then if you remember that, we can take this whole 25 to the 1/2 and rewrite it. Instead of writing 25, I'm going to write it as 5 squared, and then my exponent of 1/2 I keep on the outside. Okay, so I'm just taking my 25, replacing it with 5 squared, and I keep my exponent of 1/2. And then at this point, you have these exponents right here, the 2 and the 1/2, and you can follow our rule. We can multiply them. So then you could think to yourself, okay, so I have a 2 on the inside, and I'm going to multiply that by 1/2, and if I multiply those, the 2's cancel, and my answer is just 1. So then your answer becomes 5 to the 1, or just 5. Okay, and so that's kind of what we're doing with these examples here. So if we go on to number 2, for number 2, we have 27 to the 1/3. Okay, and so what you want to remember here is that 27 is the same thing as 3 to the 3rd power. So this 27 to the 1/3, we could rewrite this as 3 to the 3rd, and then raise that to the 1/3. Okay, and then we do the same thing where we multiply these exponents, right? So then you think to yourself, okay, so 3 over 1 times 1 over 3, I can cancel the 3's, and I get 1. So then your new exponent is 1, right? That 1 goes there and becomes our new exponent, and so then the answer to number 2 is just 3. So for number 3, we want to kick things up a notch, and we now have a numerator in our exponent besides 1. So we have 16 raised to the 3/2. Now, I don't know if you noticed in the previous 2 examples, the trick to doing these problems is to think of some number that will make the denominator of your exponent cancel. So for 16, we know 16 is the same thing as 4 squared, right? And so if we rewrite this as 4 squared raised to the 3/2, right? And then if I take these exponents of 2 over 1 times 3 over 2 and multiply them, right? So it's really convenient that I have this exponent of 2 on the inside, because then it causes the denominator in your exponent to cancel when you multiply them. And that's your whole goal, is you want to think of some number that you raise it to an exponent that will cancel out the denominator in your other exponent. Okay, so you want these to be the same if you can. So then this is just 3. Okay, and so then this becomes 4 to the 3rd, which is 64. Okay, so if we take a look at so number 4, we've got something different here. So for number 4, we have 16 to the negative 1/2. Well, we talked about at the beginning of this lesson where when you have a negative exponent, you want that to be positive, and you can do that by rewriting the whole thing in your denominator. So this is going to become 1 over 16 to the 1/2, okay? And then we just said in the previous example, well, 16 is the same thing as 4 squared, so then we could rewrite this as 1 over 4 squared raised to the 1/2, right? And then if we multiply, if we take these exponents and multiply them, I've got 2 over 1 times 1 over 2, that's going to give me 1. Your answer is 1 over 4 to the 1, which is just 1 over 4, right? So if you want to see this in a different color, right? So we multiplied these exponents, and when you multiply those exponents, that gives you your new exponent, right? And then you simplify your answer. Right? So for number 5, we're going to throw a negative inside the parentheses. Now, number 5 is actually going to be no solution. So for number 5, we have negative 49 raised to 3 over 2, and this is going to be no solution. There are a few things that tell us that this is no solution, okay? The first is the negative right there, and then that even exponent, okay? So we have negative, I should say not an even exponent, but even denominator in the exponent, okay? So whenever you have a situation where your base is negative and the denominator of your exponent is even, it's no solution. And this is going to be a little difficult to understand right now. We're going to come back to this idea at the end of chapter 7, and it'll be easier to understand with radicals and square roots. We won't do this too much more. I'll try to avoid examples like this for the first half of chapter 7 until we get to where we can handle them with square roots or with radicals. But if the exponent was odd, we would be able to do it, right? And so then that brings us to number 6, which is definitely very doable. Oh, my camera just jumped up and moved. Okay, so for number 6, we have negative 27 to the 1/3. Okay, so we've got a negative in here, but that's okay. The denominator of our exponent is odd, so we can do this. And so what you want to remember is that 3 cubed is the same thing as 27, so we could rewrite that negative 27 as negative 3 cubed raised to the 1/3, right? And then if you just multiply those exponents, 3 over 1 times 1 over 3, those cancel, and you get a 1. So your answer is a negative 3 raised to the 1, which is just negative 3. Okay? So, when you have the negatives like that, and the denominator of your exponent is odd, your answer becomes negative. Alright, and then number 7 throws something at us with fractions. So, for number 7, I have 16 over 49 raised to the negative 1/2. Okay, so we said that if you have a negative exponent, then that means you have to take your whole base and put it under your denominator. Well, that's going to be a little cumbersome to do this here because we have a fraction, so then we would have a fraction inside of a fraction, which doesn't look like any fun. A really fast way to deal with fractions that have negative exponents is to just flip the fraction. Okay, so what I'm going to do is going to flip my fraction, and so this is now going to become 49 over 16, and this is raised to the positive 1/2. So that's much easier to deal with. Okay, so now though this 1/2 is going to apply to both the 49 and the 16, so we want to be able to rewrite both of those with an exponent that has a base of 2. So 49 is the same thing as 7 squared, and 16 is the same thing as 4 squared, and this is raised to the power of 1/2, right? And so then in both cases, you would be multiplying 2 times 1/2 and another 2 times 1/2, which gives you 1. Okay, so then you have, and so this 1 is your new exponent on both 7 and 4, and so your answer is just 7 over 4. So 8 is a whole lot of fun. We've got fractional exponents, and we've got 2 of them. Okay. So for number 8, I have x to the negative 3/5 times x to the 1/5. So I'm multiplying 2 things with the same base. So what I can do is I can add my exponents. Okay? And so before we do anything else, we can just do negative 3/5 plus 1/5 is going to give me a negative 2/5. So then this is my new exponent on x. So then my first step in simplifying this, I would rewrite this as x to the negative 2/5. Okay, but we said we can't have a negative exponent in our answer, so then we could just put this in our denominator and say that this is 1 over x to the 2/5. And believe it or not, that's the best way you can write it, and as far as you can go, and you're all done. So for number 9, we have the same story. We have a to the 1/3 times a to the 4/3. Okay, and so again, we're going to add our exponents because we're multiplying 2 things with the same base. So I'm going to do 1/3 plus 4/3 is going to give me 5/3, and that is now my new exponent on a. So this becomes a to the 5/3, and that's as far as we can go. Alright, so if we look at the next page with number 10, we have x times x to the negative 1/4. Okay? Well, excuse me. For this problem, we don't see any exponent on the first x, but we know that that would be 1. Okay? So then in this case, if we add these exponents, we can do 1 plus a negative 1/4, which is going to be the same thing as 4 over 4 minus 1 over 4, which is 3 over 4. And that 3 over 4 becomes our new exponent on x, and so your answer is just x to the 3/4. Alright, number 11, we have a fraction, and we've got the same base in both the numerator and the denominator. And there are probably a few different ways that you could go about dealing with that one. I could think of maybe two or three different ways, probably 2 different ways that you could start that problem, and both are correct. But the first thing that I notice is that my exponent in the denominator is negative, and it would just be nicer if it was positive. So what I could do is I could keep my a to the 3n up top, take this a to the negative n, move that up top, make that exponent positive. Now, I've cleared my denominator. When you clear any part of a fraction, it just turns into 1. So then what we can do, if we're going to be multiplying these, we add our exponents. So then you want to think to yourself, well, 3n plus n, that gives me 4n. So that's your new exponent on a. So your answer is just a to the 4n. Okay. So then for number 12, we're multiplying those exponents. And we've got those negatives in there, so that might make you think to jump to put it into fraction form. But actually, if we multiply these right off the bat, some of those negatives will disappear. Okay? So I'm going to do negative 1/4 times negative 4 over 1. And if we do a negative times a negative, well, that turns into a positive and they disappear. The 4's cancel, and your answer is just a positive 1. So then this is just a to the 1, or just a. Right? And something that looked really messy simplified out to be something very nice. Okay. So for number 13, well, 13 I think is pretty simple. We would just do 2/5 minus 3/5. 13, we'll take a look at that one. So for 13, we have x to the 2/5 times x to the negative 3/5. So if we add those exponents, that's going to be 2/5 plus a negative 3/5, which is the same thing as 2/5 minus 3/5, which is, what is that, negative 1/5. So then this turns into x to the negative 1/5, which is just 1 over x to the 1/5. And that's the best way that you can write that answer there. Alright, so number 14, we've got 2 things inside of the parentheses and an exponent on the outside. And the 2 things inside the parentheses are 2 different bases. So what you have inside those parentheses, you can't combine with each other. You're going to have to keep them separate. Okay? So for 14, I have a to the 4th, b to the 8th, and the whole thing is raised to the 3/4. Okay? So what's going to happen is this 3/4 outside is going to get multiplied by the exponents on the inside. So what it'll look like, okay, for the a, we'll have 4 over 1 times 3 over 4. So the 4's cancel, and then we get 3. So our new exponent on a is a 3. And then for the b, we're going to do 8 over 1 times the 3 over 4 on the outside. This 4 turns into 1, that 8 turns into 2, and we get 6. So then 6 is our new exponent on b, and we get a cubed b to the 6th. And so we've got something similar going on in number 15. For 15, we have x to the negative 6th, y to the 9th, raised to the negative 1/3. So this negative 1/3 on the outside is going to get multiplied by both the exponents on the inside. Okay, so we're going to do negative 6 over 1 times negative 1/3. Right, so this is what I'm doing for the x. So double negative in my multiplication, that becomes a positive. 3 turns into 1, 6 turns into a 2, and that simplifies to a 2. So that's my new exponent on x. And then for y, we're going to have, let's see, for y, I'm going to do the 9 over 1 on the inside times the negative 1/3. So 3 turns into 1, 9 turns into a 3. You've got that negative, so your answer is a negative 3. So that's your new exponent on y, but we can't leave it like that. We can't have negative exponents in our answer, so we're going to rewrite this as x squared over y cubed, and then we're all done with 15. So for 16, you've got that exponent of 6 on the outside. Let's take a look at how we would deal with that one. So for 16, we have x to the 1/3 over y to the negative 2, and this is all raised to the 6th. Okay, so this exponent of 6 on the outside is going to apply to both the 1/3 and the negative 2 on the inside. So for the x, you're going to do 1/3 times 6 over 1, and then you get a 2. So then you have x squared. And then for the y, you're going to do that negative 2 on the inside times the 6 on the outside, and you get a negative 12. So then you have y to the negative 12. And we can't keep that negative exponent, so we're going to bring that up top. So our answer will be x squared y to the 12th. Then everything is over 1, but you don't have to write it if it's over 1. So for 17, 17 is a funny looking problem. We have x to the 2/3 times another x to the 2/3 minus x to the negative 1/3. Okay, now we've got this subtraction on the inside. So what that means is we can't combine these two right here because we have that subtraction, even though they're the same base. But this x to the 2/3, we can distribute that across. Now, to distribute that across, so I would be taking this x to the 2/3 on the outside and multiplying it by that x to the 2/3 on the inside. So when you're multiplying these two, what we would be doing is we would be adding those exponents, which will give us a 4/3. So my first term, I would have x to the 4/3, and then if I take this x to the 2/3 and multiply it by this x to the negative 1/3 over here, I would add those exponents, and I would do 2/3 plus a negative 1/3, which would turn into 2/3 minus 1/3, which would just be a positive 1/3. So then, okay, so this minus sign carries over, and I have minus x to the 1/3, and that's it. And then 18 is the last one. So for 18, I have a to the 3/2 over a to the 1/2. Okay, so we are dividing two things with the same base, so we can subtract their exponents. So I would do 3/2 minus 1/2. So what I did right there is I just did top minus bottom. And so 3 minus 1, I get 2 over 2, which is just 1. So that's my new exponent on a. And so your answer is just a. And that's the end of 711.